Alright guys, so today we're going to learn about the 3 different types of natural selection. We already know that natural selection can change a population of organisms, but today we're going to look at specifically how that population changes, because there are 3 different ways that we could see populations change as a result of the process of natural selection. We're going to be creating 3 different graphs today to represent the changes that a population can undergo. These graphs are already labeled on your notes, and what we're starting out with is what is known as a normal distribution. So a normal distribution shows you that you're going to have very few organisms on one extreme. As you move towards the average, let's say we're talking about height, so most people are going to fall into an average height. And then as you continue to get taller and taller, you're going to have fewer and fewer people who fall into that category. Now we can see normal distributions for a wide variety of traits, whether it's the height of a person, or the number of eggs that a bird lays, or how tall a giraffe is. So we're always going to start with that normal distribution. Let's say that this one is for the height of people. So we could have some short people, we could have some medium height people, and we could have some tall people. But let's say for this environment, it's actually really beneficial to be tall. Maybe those individuals are better able to reach food, so they're more likely to survive. Over very long periods of time, these short individuals, they're not going to be as able to survive. So their numbers are going to decrease. And the number of medium individuals is going to be a lot lower as well. We're going to see most of these individuals now fit into this tall category. This is showing us what's known as directional selection. So our graph, which was a normal distribution, has now shifted in one direction. So if we look at the information for this graph, the most common phenotype was medium, which was our average phenotype. And now the most common phenotype, this new highest point on our graph, is for the tall individuals. And we know this because the graph has shifted toward one extreme. So our whole graph has gone from having its highest point over medium, and it shifted over towards this extreme side where most of our individuals are now tall. And this will lead to more tall individuals. A great example of this is the neck length in giraffes. Oops. They started out where you would have had a normal distribution, where some giraffe necks were a little bit shorter, you had most of them with an average length, and some of them had really tall, long necks. And now over time, those individuals with the longest necks were most able to survive, which is why we see most giraffes with these very long necks. Now, another way that populations could change due to natural selection is what we call stabilizing selection. We're going to have the same categories again, so we're going to have our short, medium, and tall individuals. And just like before, we start out with the average, that medium height, as being the most common. And maybe that really is what's best for this environment. So if medium individuals are better able to survive, then they're going to continue to be the most common phenotype. So what we're going to see is that this graph is going to narrow, and we're going to have the highest point over our medium individuals. So this graph is going to move in towards that average phenotype. So our most common phenotype was medium, which is our average. Most people were medium height, And now our new most common, still medium. That is still the most common phenotype. In fact, it's more common than it was before because we see a decrease in these extremes on either side. So we know this because the graph has narrowed around the average trait, which is going to lead to more average individuals, which is also our medium height in this example. A good example of this is the number of eggs laid by a bird. If they lay too few eggs, then there's a lower likelihood that someone will survive. If they lay too many eggs, then they have a hard time feeding all of those young. So the most common that we see is probably about 3, maybe 4 eggs for a group of birds, right there at that average size. Now, the last way a population can change is what we know as disruptive selection. So this time I'm going to label my graph the same way again, short, medium, and tall. And for this environment, being average, being medium, is least likely to survive. So in this environment, you are more likely to survive if you are one of the extremes, either short or tall. So we see a decrease over that average or medium trait. So to fill out our information, the most common phenotype was medium, just like we started with all of the others. But now our most common phenotype is going to be short and tall. Both of them are equally likely to survive. We know this because the graph divided toward both extremes. So we see peaks over both the short and tall phenotypes. So this will lead to more short individuals and more tall individuals. We're going to see fewer of those medium or average individuals in this case. And a good example of this is in salmon. So the size of salmon for them, it's best to be either small or large, but not average. So the small salmon have an easier time reproducing because they can sneak around into other salmon's territory. The large salmon have a better time reproducing because they can maintain their own territory, but the medium salmon, they're not small enough to sneak into someone else's territory to reproduce, and they're not big enough to maintain their own territory. So those medium-sized salmon are actually decreasing, and we're seeing a lot of either extreme, both small and large. So what you're going to do now is use the information that we've put together in these notes to answer the questions that you have on the worksheet for class today.